All right, let's go. There is a thing called steampunk. Steampunk is a decor. It makes it look like it takes something modern and makes it look like it is powered by an alternate energy source, which it turns out that it's exactly what I made. The illusion I wanted was the gear here is generating electricity, which turns on the lights. That's why they come on in stages too. The gear train wasn't the original idea. The original idea was supposed to have a little firebox up top that would have a little fake fire look, and then a little bellows pump would start moving. And when that happened, I would have little glowing coals, and then the lights would start turning on. But that might have been silly, and probably couldn't have seen it up there anyway. So I went with the gear option. That gauge there you can't see because it's too far away. It's a volt gauge. It turns on when the gears turn off, giving you the illusion that it's powered up. I can turn the gears off with that copper-looking knob. The red knob turns off the down lights. My theory there was these lights are going to be bigger and brighter, thus hotter. So turn those off. And then if you wanted the accent lights or the grid lights, you'd hit the blue one. And there's another angle of it. There's no chain tensioner in there or anything, and that's why we have that slack. But I'm fine with it. That's my lamp. I really like it. I think it turned out great. It's not a boring lamp where you just turn it on, it lights up, and that's the end of it. It does something. It's unique. And I think the clear glass antique looking bulbs up against the distressed finish there of the box, I think it really looks good. I have a lot of footage of how I made it. I'm just going to blow through it because it's, 3 months long. So I'll just speed it up. You'll see the most of it and kind of what's going on here. Hello and welcome. Today is the day where I start the final assembly of my lamp I'm making. It's your pretty standard over the kitchen island light. I don't know, months ago, probably a year ago, honestly. I was talking to the lady at the Home Depot looking at lamps. I was like, I don't like any of these. I'd rather just make one. And she's like, yeah, all right, whatever. And we left, and we never had any more discussion about it. But secretly, I've been planning and making this thing for quite some time. I got serious about it about 3 months ago, started thinking about it, ordering parts, working on it. The parts are all here. Parts are all made. Parts are ready to install. So I think I could have this thing up in the next few days. It is Tuesday now. I'm thinking by Thursday, this will be a functioning lamp. So I don't want to chew up my pipe, so I just picked up this Superior Tool internal pipe wrench. Here we go, help me tighten everything down without scratching up the outside of the pipe. And it's just a cam. May or may not be very strong. We'll see how that works. So this is the grid, as we're calling it. Me and my dad, who's helping me with this thing. It's going to go on the outside of the light. I don't know if I'm going to do a thumbnail showing it or if I'm going to do an intro video showing it first. See, good YouTubers, they usually have like a storyboard and writers and they plan ahead. I don't do any of that. So this is all being done on the fly. Anyway, this is the grid. I need to get all the wiring routed through here up into these little support arms and make all these switches and the power gauge over there work. So that's not going to be fun because I got to take this thing back apart again. Gonna have to do some wiring extension for the switches and yeah, a lot of stuff. Now the only way I could see to get this thing assembled was to install these unions here. That's why I got unions in the middle. That'll also help me be able to take it apart so I don't have such a huge part I'm working with. That's easier. These are all just a pinch loose. So I want to tighten all those down the best I can. If I can, I may or may not be able to. But even if they are a little loose, once it's attached, it's really not going to matter. That wasn't so bad. We got all the light strings anyway, routed through there, all 5 for this half. These are the angles that come up, support the center. So this one is pretty much done. It'll need some fine tuning to make sure these are upright, but for the most part, the string is in there and it's good and tight. So let's do the next one. This little tool is turning out to be quite handy. All it needs is a little twist, get the fitting loose, and out it comes. So yeah, not bad. It looks like a mess in the photo. I'll give you that. But in person, this is coming along great. So this is all done, tightened up. Rope is ran for the wires. So the next step would be to put it onto the box. Here's the box. It is 3/4 inch maple, distressed to give it that old-timey antique look. I think most people building lamps like this use a railroad tie. I didn't want that look, finish, or material, so went with this. Well, I started running the wiring for the grid lights, and a little while later I am out of wire. So I've gotten half of it wired in there. So 5 lights, total of 10 wires, and I've used 50 feet of wire in this thing so far. So it's a little more wire than I thought, because I only have 50 feet. 25 feet red, 25 feet black. Reason I'm using black here is because that's the color the little bulb sockets come. Red and black, so I just kind of rolled with it. Yeah, so it's going to be delayed another week or so just because of my lack of wire. Now I do have plenty of low voltage wire, 60 volt and lower. It's for my, cars, trucks, boats, tractors, whatever I have. Usually I don't do any house stuff, so I don't have any wire rated for 120 volts. This is 300 volt 20 gauge, same as wire that came in the light sockets. Now the wire I have, it'll handle the wattage and the power without issue, no problems. But should this thing burst into flames, catch fire, and the insurance sees, oh, you didn't use the right kind of wire, because the wire I use will probably survive in a fire, I don't want any problems. So I'm using actual fixture rated wire, which is crappier than the wire I'd usually use, but it's to code. Okay, here we are on the bottom board. This would be called a DIN rail. You can also see the motor and the drive mechanism, how it works. It's pretty straightforward. How I hook that up is kind of neat too. I'll show you that in a second. Anyway, power is going to be coming in over on this side of the light. So I want to go that way with my electronics. So the first thing I have is a breaker, which is kind of unneeded because the house has a breaker anyway, but it's there. Have a little terminal block for the line, terminal block for the load. I then have a time delay off, which will turn off the motor. I then have a 12 volt power supply, which will power the motor. So we have power, timer, power supply, and that's the first stage. After the motor starts winding up about halfway, we have a timer, which is backwards. There we go. We get a timer that will delay the startup of the grid lights. We then have a contactor, because I don't think this thing is going to be able to handle the power load of the grid lights. It says it will, but just barely. So 20 amp contactor. I then have another timer for the down lights and another contactor. And those are electronics, so it's a simple matter of wiring them up. Yes, brings me to the next point.
wire furls, I don't know. These things. While technically not required on code in the US, it is still a good idea to use them. Especially since I'm using the stranded wire. When the little clamps on these things clamp down on it, it kind of destroys the wire. It doesn't really make a good connection. So I'll be using ferrules, whatever, where needed, or everywhere. We'll see where this takes us. Wire I'll be using is your standard THHN 14 gauge wire, sold by the foot at the big box home improvement stores. So pretty standard stuff, I think. Blue apparently is our 14 gauge. This is a pretty dumb design of this contactor because A2 up top here is what activates our electromagnet, turns the solenoid on, and it's blocked by the bottom screw. So A2 blocks the bottom terminal, so I can't get to it. So there's no point to hooking those up right now until I get the bottoms in. Just kind of silly. So guess I'm hooking the bottoms now. All right, let's give it a test. The first bulb, well, like I said, the layout is in order. So first you have the drivetrain, then you have the grid lights, then you have the down lights. So drivetrain, grid lights, down lights. Let's see if it works. There's a plug adapter here. Looks good. And oops. So I might as well show this to you real quick. We have you may hear a little clink there, which I'm not against. Originally I wanted this thing to sound like, you know, you're going up a roller coaster, clink, 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 clink as it turns, but no reason to. So you can watch that gear and you kind of see the problem I'm having with it. It's a little bent. That's just how they make things in China, I guess. So it needs to get fixed. So with the corners all set, put a straight edge across the bulbs and make the middle ones all line up. Now this one is kind of my questionable one because of how high up it needs to come. Same with this one. They're a little sloppy loose, if you will. So that's where some JB weld is going to come into play. And I'll put some on the threads right there and on the threads right here. That should get them all pretty close. It's the quick weld, not the 24-hour dry kind, so in 7 minutes those shouldn't move anymore. Now it's a simple matter of installing all the bulb sockets, which is, 20 splices by itself, so that'll be fun. I got a little 10-pack of lamp sockets, and if you notice, red and black wire, which is why we have red and black wire there. I think it will also be a good indicator of which, when you're working on this, which wires do what. So that was kind of theory to use the red and black wire instead of white and black like you typically see in a house. But anyway, so yeah, got to splice all those wires together. Now with such small wire, it's not entirely easy, but it's not really difficult either. I will be using these TE 800-2500 crimp splices. That is what they look like. Usually you just use the one to crimp it, but I'm going to be cutting them in strips of 3 so I could use the an insulation crimp as well as a conductor crimp. So basically I need 3 of these for each wire. So I need basically 20 of those. Now I will be staggering the crimps, so they won't be straight. They will be slightly staggered like so. Using my automated wire strippers, we have the smaller gauge, which is cutting it perfectly. After they are on and heat shrunk, I'll pull the wires back in to get the bulb into the little socket holder, and everybody should be happy. And that is what it looks like. So just heat shrink time and it's done. So I'm gluing in the sockets now. So I measured out all of the little fittings here to make sure they were all going to line up. Doing so, I knew it was going to be kind of pointless because these sockets don't actually fit the fittings. What they fit is the 1/2-inch nipple inside of there. So what I probably should have done is made sure all the nipples were in there, in that correct place. And then all the bulbs would have been even if the fittings weren't. But it'll be good enough. I don't think anybody will ever be able to profile and tell. But we'll see. I'll probably notice. So that won't be fun. Alright, I labeled them all. So this should be bulb number, I forget. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, or 7. Well, yeah, 7 of it. Yeah, 7. So all I do is, with one hand over here, pull the wire up, brings up the bulb. I put the bulb straight, and push in the fitting, remove the bulb, and then push in the little plastic liner, which is actually being held in there. And that's it. So that bulb's done. Alrighty then, it is now time to crimp more of these wire funerals onto the end of these wires. What I need to go do is figure out if they're using black for the hot and red for the line or the common, or if they're using red for the hot and black for the common. Usually when you see red and black wires, it's low voltage. Red is the positive, black is the negative. But I don't know if they did that here, so I gotta go find that out. Does it matter? No. After some slight testing, turns out the red is the center, which would be the positive or the hot in a home situation. Meaning our black is our common or our ground or our line. Yeah, working on low voltage stuff, like 12 volts, red and black's common. But when you switch over to home stuff, then it's not so common. Also, I say low volts like 12 volts. No, 120, 110 volts, that's low volts. The 480s and the 600s, those are high volts. So it's just confusing. Different wiring worlds, I suppose. Different terminology and what you're used to. But red and black, that's what I'm used to. So anyway, now it's just a matter of hooking all those up. So that'll take a few minutes. Alright, the downlights are done, so in a second I'm going to power those all up, make sure they all work. But before I do that, I want to try this. Well, not try it. do this. That is glue our bulb socket into my downlight base. Give it some time to set up. So I just use a piece of junk mail. Most people when they mix in JB Weld, they use cardboard. I don't like to waste the cardboard, so I use junk mail. And they keep sending it to me, and I keep not looking at it and keep mixing glue on it before throwing it away. Okay, I have this hooked up, kinda. Light bulbs are all in. And I have 2 wires coming out to power the little junction block there. All right, let's see if this beauty lights up. Hey, looking good. Now it is time to wire in these switches. These switches will turn off the contactor, which will control either the downlights or the ambient grid lights. I'll be using black wire for the blue switch and red wire for the red switch. The reason I'm using red is because I don't think I'm gonna have enough black. Pretty easy reason, huh? I know, silly. So just getting that prepped. Should be a pretty easy process the way I plan on doing this. And just like before, I'm going to stagger the wires so we don't have any joints too close together. Now I really get a first look at what this thing's going to look like when it's all done. Let me put in the light bulbs to give you an idea. I think they'll be bigger on the next go around. And also this lamp socket isn't in there exactly straight, so I think I need to remake this one. Not a big deal because I have a spare one of these and a spare lamp socket. But that kind of sucks. It is definitely not light, but with my little wiring access hole here, that is pretty much the only reason I'm going to be able to get to any of this stuff. And if I ever need to change anything with the drivetrain, it can be done from the top, but good luck. Like changing out this gear, the one we have in here now is bent, so I need to get the replacement. When it gets here, this lamp is basically going up the next day. So I'm kind of taking my time doing this till I get the replacement gear. This one's all bent. So this is our red switch, which will turn off our contactor here. Got plenty of wire for that. Wire that up. And the blue switch is the black wire over here, which I almost have enough for, but not quite. A few more inches and I would have done it. So I'll extend that a little bit. That kind of sucks, but
I'll spare you the details of the mathematics that went into figuring out where this is going. But we got the first leg in, wires hanging out. A lot of work to get to this point.
Now it looks like a floor flange, and it is, but with a little trick up its sleeve. It can move. That took some figuring out.
Didn't want a fixed pipe up there. I do because it looks good. What I didn't want was chain. The problem is if you ever bump that lamp or hit it or something, I mean, something's going to break if that lamp needs to get moved. I wanted a way to break away, if you will. Some way for it to wobble if it needs to. It simply just wasn't going to happen with the floor flange, so I'll show you how I did it.
all right, so on the top, we're going to have a floor flange mounted. It's not a floor flange, it's just a flange. People call them floor flanges, though. Anywho, I then got 3/4 inch pipe, but it's a 1 inch or 1 1/4 inch, one of the two, flange, and I got a 3/4 inch nut. I then rounded the nut on the grinder to look like that, and then cut the end of the pipe off. Now I only need to do this on the ceiling side, not on the lamp side. So down here,
full threads are fine. But basically, pipe goes in there and gives you the ability to move it, but still plenty strong. See what I mean? I think it's pure genius. I was thinking about using 4 universal joints. The thing is a universal joint with a 3/4 inch hole in it to take this pipe, actually 1 inch hole. Godly expensive, so I didn't go that approach. And honestly, I'm glad I went with the flange. It looks better. So that's it. It is heavy. It was expensive. We probably could have bought a lamp at Home Depot for what this thing cost, but you're not going to find anything like it. I think it is truly unique. Well, that's it. I hope you enjoyed my lamp. Hope you enjoyed my video. And let me know what you think about it. I really like it.